to Excellenceinexam. So this is the platform where we will be providing lessons, specifically in physics, mathematics, chemistry, and biology. So these are the subjects that we will be looking at. I'm your teacher, Simon, who has a degree in both mathematics and physics. So today we'll look at the fourth topic in grade 12 syllabus, which is basic electronics. So under basic electronics, we have started with the subtopic, which is fermionic emission and electrons. So we need to understand what is all about basic electronics. So under basic electronics, we need first of all to understand the fermionic emissions and electrons. So what is a fermionic emission? So fermionic emission as a process simply means the discharge of electrons as a result of a metal being heated up at a very high temperature. So according to our definition, we are saying this process is defined as the discharge of electrons from the heated metal surface. This happens when the metal conductor is heated to a very high temperature. So this process can only occur when a metal surface has been heated up to a very high temperature. In short, we say when it is heated up to red hot, because it is only at that stage when the electrons that are on the surface of the metal gains enough kinetic energy. They gain enough kinetic energy so that they can escape from the metal surface. And once they escape, because these electrons we are talking about, they are negatively charged particles. So immediately when they escape from the metal surface, due to high temperature, they are going to be attracted by the anode, which is a positively charged terminal inside the fermionic tube. So this enables the electrons to gain enough kinetic energy to escape from the surface of the heated metal. So that is the process we call fermionic emission. Note, these same charges we are talking about, we are saying when the metal surface is heated up, the electrons gain enough kinetic energy to escape from the metal surface. But we need, first of all, to understand what are these electrons. So electrons specifically, we are talking about the charges. Now, before we go further, we would like to look at the types of existence of the charges. Now, basically, there are three ways in which charges exist. There are three ways in which charges exist. One, charges can exist as electrical current as they flow through a conductor. That's number one. Charges can exist as electrical current as they move or flow through a conductor. Apart from that, charges can also be found on the surface of an insulator. Charges can also be found on the surface of an insulator. Now, what type of charges which can be found on the surface of an insulator? These we call them static charges. So that is the second way in which charges are able to exist. The third one, this is when now the charges are able to exist in a vacuum. And when the charges exist in a vacuum, we are saying these are electrons. The same electrons that are released when the metal surface is heated up, they pass through a vacuum and exist inside to ionize the air, the particles that are inside. So these are the three ways in which the charges exist. Now, after these charges, the electrons have been heated up and they escape from the metal surface, they pass it through a special instrument or a special tube which we call thermionic tube. So what is the thermionic tube? From the word itself, thermionic, it means that this is a special tube in which the charges or the electrons travel as a result of thermionic emission. So we cannot be talking about the thermionic emission minus acknowledging the thermionic tube. Because the application of the thermionic emission can be appreciated once we understand the thermionic tube. So this is a special tube in which an electrical current is produced through the process called thermionic emission. That is thermionic tube. Now, the same thermionic tube has got certain components, or rather the parts that makes up the thermionic tube. So the following are the parts. One, the thermionic tube is made up of a cathode. And when we say a cathode, this is a negative terminal. Secondly, it is made up of the anode, which is the positive terminal. The third, it has got the glass tube, the tube itself which encloses the vacuum. And the last one, it is also made up of the battery as well as the vacuum itself. So these are the components of the thermionic tube. As you can see, we are saying the following are the components of the thermionic tube. One, we have the cathode, which is also called the metal filament. The second one is the anode, which is the positive terminal of the power supply. The glass tube, which encloses the vacuum, the battery itself, and also the vacuum. So these 5 are the basic components of the thermionic tube. Let's look at the structure of a simple thermionic tube. This is a simple structure of a thermionic tube, where we have these are the parts of the thermionic tube, where we have this is the filament, which is called the cathode filament. It is negatively charged. This is the glass tube, and this is the anode, which is positively charged, which is a metal plate. The vacuum itself, that is the absence of air, and the high voltage battery. So this is the high voltage battery, which has got the negative terminal as well as the positive terminal. Now, when we connect the cathode filament, which is the negative terminal, to the negative terminal of the battery, and we connect the anode, which is the metal plate, to the positive terminal of the battery, then we are allowing the voltage to flow. The voltage to flow. Now, as the voltage flows, we know that this current which is going to be flowing from here, it is the electron. Now, electrons flow from negative going to positive. It's different. We need to understand one thing there. We have 2 types of current. We have the conventional current, which flows from positive going to negative. And we have the electron flow, which flows from negative going to positive. So what we are talking about is the flow of electrons. So as the voltage, as the battery provides the voltage, this voltage keeps on rising and releasing the electrons. These electrons are going to be released. Why? Because the filament is going to be heated to red hot. And once it is heated to red hot, to high temperature, electrons will be produced, will escape the metal surface. And once this happens, these electrons will flow from the negative going into the cathode tube. And because they are negatively charged, they are going to be attracted toward the positive terminal or the anode, the metal plate. So in this way, we are going to see some sparks that are going to be produced inside the thermionic tube. The other thing that we need to understand is, why is this a vacuum? Why do we have a vacuum and why don't we allow a certain amount of air to be inside? It's probably because these electrons, they can ionize the air particles inside the vacuum. And once they ionize the air particles inside this vacuum, then the application of the thermionic emission cannot be appreciated. In short, we are not going to have what we expect at the end of the experiment, because the air that is going to be found inside, they will be ionized. And once they ionize, they will become charged. That's why when doing this experiment, we need to make sure that the vacuum is completely without any small amount of air, so that we avoid the ionization of the particles inside. This is how the cathode, the thermionic tube operates. Let's look at notes. The low voltage battery acts as the power source to heat the filament. So this high voltage acts as the primary source, so that it provides the voltage which is going to heat up the filament. So this filament will be only be heated once this battery provides the voltage, so that it heats up this filament. Now, once this filament becomes red hot, then the electrons on the metal surface of this element will release the electrons, and these electrons will move in this direction, being attracted by the positive terminal. Now, electrons will only be attracted to the metal plate if the metal plate is positively charged. So this can only happen when this metal plate is positively charged or positively connected. So we need to make sure that this anode, the metal plate, is always connected to the positive terminal of the battery. And this is what we have been told. The electrons can only flow from the filament to the plate. This is opposite to the flow of the convectional current. Now the question is, let me go back here. Electrons can only flow from the filament to the plate. It can only flow from this filament, which is a cathode filament, to the anode, because of the potential difference between the two terminals. The potential difference between the two terminals enables the electrons to flow from where the ions are concentrated to where they are not concentrated. So that enables the electrons to move from the filament going to the anode. That is the point. Now, you may ask a question to say, how can we increase the speed or the rate at which the electrons travel or move? A simple answer is, we can increase the rate at which the electrons move from the filament to the anode by increasing the voltage supply. So once we increase the voltage supply, maybe by putting a battery that has got a high EMF or the voltage, then by increasing that, you have increased the acceleration or the rate at which the electrons will move from the filament going to the anode. So thank you very much. This is the end of the lesson on basic electronics. Please, if you have questions, please post them, comment on the platform, so that we can try to provide more lessons. Where you think you are behind, please comment so that we may try to learn together. Thank you very much for watching Excellency in Exam. Bye-bye.